All right, mathletes, here we are looking at solving linear equations. Remember, linear equations are often written in the forms where they're called linear equations because all of our unknowns are just going to be degree 1. Notice a degree 1. And over here, we have a degree 1. Even though it's a y, it's a first degree linear equation. Okay, so those are some examples that we have probably hopefully seen before. Now let's look at solving them. Okay, so as we're solving in unknown equations, we're always trying to isolate our x, and we're going to try and undo the operations to get x by itself. So first thing I'm going to do is to undo my minus 1 on this side, so I'm going to add 1 to both sides. So then I'm going to get 4x is equal to 8. Okay, and now I have 4 times x, so to undo multiplication, I divide by 4 here, so I get x is equal to 8 divided by 4 is 2. I should check by substitution, so if I see that 4 times 2 minus 1, what is it equal to? 8 minus 1, which is equal to 7. I've verified my solution. Okay, always a good process as we're solving for x. Okay, on letter B here, so as I'm undoing these, I'm again trying to find out what x is equal to. I want to undo my outer later, so since the minus 3 is in the parentheses, I'm going to deal with this 1/5. So multiplying by 1/5 is the same thing as dividing by 5. So to undo dividing by 5, I'm going to multiply by 5 over 1. So if I do that here, I got to do it on the right side. So those will cancel out, and I'm left with an x minus 3 on this side, and negative 1 times 5 is a negative 5. Okay. At this time, I'm going to add 3 to both sides, add 3 to both sides, and I get x is equal to negative 2. So again, I want to verify my solution. So I'm going to do 1/5 times negative 2 minus 3. Well, negative 2 minus 3 is negative 5, so I do 1/5 times negative 5. And then I know I can make this a fraction by putting over 1. And I get negative 5 over 5, which is equal to negative 1. So I've verified my solution. Okay, so let's look at a couple more examples here. Okay, so equations with a repeated unknown. In situations where there's a repeated unknown, what we want to do is we want to expand them and get rid of any of our brackets, collect our like terms, and then solve it as we did before. So let's look at how that's going to look. Okay, so notice I have 2 unknowns. I got an x here and an x here. So to isolate those is difficult, but they're like terms, so we can combine them. Okay, so first strategy is to distribute to get rid of our parentheses. So as I expand this, okay, 3 times 2 is 6x. 3 times negative 5 is negative 15. Negative 2, so remember that this negative is tied to the 2, so I got to distribute that across. So negative 2 times x is minus 2x. Negative 2 times negative 1 is a plus 2 is equal to 3. Now that I've written them without parentheses, I'm going to group my like terms. So my x's together. 6x minus 2x is 4x. Okay, and then I'm going to group my constants together. Minus 15 and a plus 2 is going to be a minus 13. And then I'm left with equals to 3. So now, as I did before, I'm going to deal with undoing things to get x by itself. So opposite of subtracting 13, I'm going to add 13 there and add 13 here. So now I've created a simpler problem for x is equal to 16. Divide by 4, and I get x is equal to 4. Again, I want to verify and check my solution. So I'm going to do 2 times 4 minus 5 minus 2 times 4 minus 1 is equal to what? Okay, so simplify step by step here. So I'm going to simplify the parentheses. So I'm going to have 2 times 4 is 8. 8 minus 5 is 3. Okay, and then I have minus 2 times 4 minus 1 is 3. Okay, and then I have 3 times 3 is 9. And negative 2 times 3 is negative 6. And 9 minus 6 is 3. I have now verified my solution. Okay, so let's go ahead and try our final 2 examples here. Okay, so again, on this one, notice I have x's, 2 x's. They're on different sides of the equations. Okay, and I have 2 constants. Okay, so I think the easiest thing to do here at this point is get all my variables on one side and all my constants on the other. Okay, so I'm going to minus 2x on this side, and I'm going to minus 2x on this side. Okay, over here, since I have a positive over on the right side, I'm going to add 4 on this side and add 4 on this side. So by doing so, okay, those are inverse opposite operations, so are those. So those will cancel out. 3x minus 2x is x, and 6 plus 4 is 10. Okay, so I got x by itself. So to verify it, I'm going to do 3 times 10 minus 4. Well, that's 30 minus 4 is 26. Now let's do the right side. 2 times 10 plus 6 is 20 plus 6, which is 26. They're equal. Verified our solution. Okay, so in B, on this one, the first thing I want to do is get rid of my parentheses. So I'm going to distribute my negative 3 through, again, making sure I carry that sign. So I'm going to have 4. Negative 3 times 2 is minus 6. Negative 3 times x is negative 3x is equal to x. Okay, so what I'm going to do is I'm going to recognize that I have an x term here and x term here on equal sides. So I'm going to get all my x's to the right side. So by doing so, I'm going to add 3x and add 3x. So what do I end up getting? X plus 3x is 4x on the right side. Those cancel out, and 4 minus 2, I get negative 2. Okay, so then I'm going to divide by 4 on this side, divide by 4 on this side, and I'm going to get x is equal to, well, negative 2 over 4 is going to simplify to negative 1/2. Okay, so to verify my solution here, I'm going to do 4 minus 3 times 2 plus a negative 1/2. Okay, well, to add my fractions here, okay, I'm recognizing I'm going to have a common denominator. Okay, so I'm going to multiply this by 2 over 2. So what I'm going to get is 4 minus 3. Now in the parentheses, I'm going to get, this was over 1, so I get 4 over 2, which is equivalent to 2, minus 1/2. Okay, now I have a common denominator. I can simplify that. So I'm going to get 4 minus 3 times 4 minus 1 is 3 halves. Okay, so continuing on simplifying that, I'm going to do negative 3. You can treat this over 1. Negative 3 times 3 is negative 9 over 2. Okay, well, again, I have an issue of trying to subtract and not have common denominators, so I'm going to multiply this by 2 over 2. And remember that I can put this as 4 over 1. So 4 can also be written as 8 over 2 minus 9 over 2. Now I have a common denominator, so I get negative 1 over 2. And here I've verified it's equal to x, which was negative 1/2. So now I have checked my solution. That concludes the notes for tonight. Go ahead and highlight any questions you have and bring them to next.